Look at several different ways to graph linear equations. There are some ways that are easier than others, some that are more sophisticated than others. So let's just start looking at the different techniques and sort of go from the easiest to the more sophisticated type technique. We need an equation to work with. So let's start off with 2x plus 3y equaling 12. Now the first technique that I want to look at is a technique with which you are just going to pick some ordered pairs. You're going to find an x and a y that solves the linear equation and plot it, followed by a second one and a third one to verify your results. To do this, you can start off with basically just picking any x value that you want and make the appropriate substitution. And carry out the multiplication. I'm going to subtract off the 2. Divide by 3. And you've got the second half of the ordered pair. Now for another point, you're going to repeat the process. This time, just to do things differently, we could pick a y value, plug that y value in, and go look for an x value. So let's go with a y value this time, and let's say it's a 2. Again, we come up to our equation, make the substitution. I'm going to subtract off the 6. Divide by 2. And again, I've got the second half of the solution. And like I said a few minutes ago, we need to do a double check. So you will come back up, and to do a double check, you are basically coming up with a third point. So 2 points will determine a line, but the third point will determine that you are all in fact, graphing the unique line that is the solution. So I'm going to come up with another, say this time, another x value. Make the substitution again. Carry out the multiplication. Subtract off the 10. Divide by 3, and you've got the other half of the solution. Now this is a very easy process, as you can see, but with the numbers that we're coming up with, you can tell it's probably not the best way to do it, because we are coming up with some strange values, or some fairly hard to graph values. We'll come in here and do the best job we can by hand in finding the line that those values determine. I'll go x value 1 and then go up to 1, 2, 3 and approximately 1/3. X value of 3 and go up to 2. X value of 5 and go up approximately 2/3. And as you can see, these 3 points do approximately fall on a straight line. So the linear equation, or the straight line that these 3 points determine, is approximately right there. Again, not perfect, because it is being done by hand. Now, when it comes to plotting points and finding a linear equation by that technique, the best points, or at least the easiest points probably to find, are the y-intercepts. And graphing an equation using y-intercepts is another technique within itself, as a matter of fact. If I get rid of the points that I had, there are 2 points in particular, like I said, that are the easiest ones to come up with. And those are the points. The first one is the one that has an x value of 0, and the second one is the one that has a y value of 0. Note that when you plug in 0 for x, all that's left is the y variable. Dividing by 3 gives us a nice, easy to find value. And we can go back and do the same thing again. So this time we'll plug in the 0 for the y. Again, solving for the variable becomes quite easy. And we see that our y-intercept, as we almost suspected here from our drawing, was in fact 4. Our y-intercept and our x-intercept is a 6, and the drawing was a little bit off on that one. So another technique, besides just plotting any point chosen at random, is to plot x and y intercepts. Again, a y-intercept is found by plugging a 0 in for x, and an x-intercept is found by plugging a 0 in for y. And that is a good technique to use because those are two very easy points to plot because they are right on the axis. Now another graphing technique altogether is one that would allow us to put the graphing calculator to use. If we go back to the same equation and solve for the y variable, we'll subtract the 2x from both sides. Divide by 3. And look at the result. This equation in this form would make it very easy for us to pick some more x values, plug them in, and find the y value that goes with them. But even easier than that, we can go to the graphics calculator. We'll hit the y equal to button. And since we have solved for y already, we can put in what we found. Negative 2/3 x plus 4. That's the solution we found for y. So I'm going to hit a zoom standard. And we see the line that we saw earlier with, and if you go to the graph, you can see the graph of the line. If you go to your table, you can see the x and y values, some of which are the ones we found. But again, solving for the y value, or for the y variable, gets the equation in the form that can easily be put into your calculator, and you can see your graph and verify that the graph that we did by hand with pencil and paper is in fact the correct graph. So those are basically going to be your main techniques for graphing. First of all, just choosing an x value, plug it in, find the y that goes with it. Choose a y value, plug it in, find the x that goes with it, or pick zeros for x and for y, therefore locating the x and y intercepts. Or your last alternative is going to be solve for y so that you have something that can be plugged into the calculator, and it can give you a very nice representation of the graph. Now there are two graphs that we need to pay special attention to. Graphs that both aren't handled very well by your calculator. If we look at a couple special cases, and that's what I usually call these two particular graphs on several different occasions. If we have an equation like y equal 5, for example, now that actually is one, in fact, that your calculator can handle. If we clear out the equation that's there and put y equal 5 in and graph that, is what we see from that graph is a horizontal line. So the y equal to any constant, regardless of what that constant is going to give us a horizontal line. Horizontal line passing through the y-axis at that value. So whatever that constant value is, this graph, that line, will pass right through it. Now the other graph, one that your calculator won't handle for you, is x equal to a constant. Say x equal -3. That's the second one of your two special cases, as I call them. And as you could almost guess, if y equal to a constant gives you a horizontal line, an x equal constant is going to give you a vertical line. In this case, it's going to be a vertical line passing through -3. And every graph where you have an x equal to a constant is going to look the same. So it's really easy to spot one of these graphs. This is the only two equations that give you either horizontal or vertical lines. And again, those will be referred to, I'll refer to them in the future as your special cases when we talk about other algebra applications and topics. So start getting familiar with these two graphs.